A phone company just built a car that beat Porsche at the Nürburgring, and the way they built it is going to change cars forever. 3 years ago, Xiaomi was known for making cheap smartphones and air fryers. Nobody took them seriously when they said they were going to build a car. Engineers laughed. Journalists laughed. The whole automotive world laughed. Nobody is laughing now. The Xiaomi SU7 Ultra just ran the Nürburgring in 6 minutes and 46 seconds. That's faster than a Porsche Taycan Turbo GT. But the speed is actually the least interesting part of this story. The real story is how they built it, because Xiaomi didn't just make a fast car. They threw out 100 years of car-making tradition and started completely from scratch. Here's the thing most people don't think about. The way cars are built today is basically the same way they were built in the 1950s. You take flat sheets of steel, stamp them into shapes, and weld hundreds of pieces together. A standard car chassis can have hundreds of individual parts held together by thousands of welds. Every single weld adds weight. Every single weld vibrates. Every single weld is a place where things can go wrong over time. Engineers have spent decades trying to make this process slightly better. But the core idea never changed until electric vehicles came along and made everything even harder. An electric car needs a massive heavy battery pack. The most logical place for it is under the floor. But when you bolt a giant battery box underneath like a suitcase, it becomes dead weight. That makes the car heavier, which means you need a stronger chassis to hold everything together, which makes it heavier again. It just keeps spiraling. Tesla saw this problem and came up with a clever solution. Instead of welding dozens of steel pieces together, they started pouring molten aluminum into giant molds to create huge single-piece sections of the car. They called it gigacasting. Instead of 60 separate parts welded together, you get one big piece straight out of the mold. Fewer joins, less weight, faster to build. It was genuinely brilliant thinking, but it had a hidden problem that stopped every other car company from copying it properly. When you pour molten aluminum into a mold and let it cool, the inside of the metal is actually weak. The tiny structures inside the metal are all mixed up and pointing in random directions. The part looks solid, but under real stress, it can crack. The standard fix is called heat treatment. You put the cast part into a massive industrial oven and bake it at extremely high temperatures for several hours. This lines up those tiny internal structures and turns a weak part into a strong one. It sounds simple, but when you heat a giant piece of metal to those temperatures, it doesn't just get stronger, it also warps. It bends in tiny but very important ways. And when you're building a car where every millimeter matters, even a small bend means doors don't close right and suspension parts don't line up correctly. So manufacturers were stuck choosing between two bad options. Skip the heat treatment and have a part that's the right shape but not strong enough. Or do the heat treatment and have a strong part that's slightly bent out of shape. Every major car company tried to solve this for years. None of them could. Most eventually just accepted it as a problem that couldn't be fixed. Xiaomi refused to accept that. Their engineers went through every aluminum alloy available on the market. Not one of them could be strong, flexible, precise, and require no heat treatment all at the same time. The perfect alloy didn't exist. So Xiaomi decided to build it themselves, and the way they did it is one of the most interesting parts of this whole story. They built an AI system called Material Genome. They fed it everything known about metals and material science, then gave it one mission: find a formula for an alloy that needs absolutely zero heat treatment after casting. The AI tested over 10 million different alloy combinations in computer simulations. To put that in perspective, if a human scientist tested one new formula every single day without ever taking a day off, it would take over 27,000 years to test that many combinations. The AI did it in a fraction of the time. The result is called Xiaomi Titan's Metal. It's a fully patented alloy that belongs only to Xiaomi. When it cools down after being poured into a mold, it comes out already strong, already the exact right shape, and ready to be used immediately. No oven, no warping, no compromise. Now they needed a machine big enough to use it properly. Tesla's Giga Press runs at 9,000 tons of clamping force. When it was first revealed, automotive journalists called it the engineering limit of what humanity could build. Xiaomi built a 9,100-ton version called the hypercasting machine. This thing covers the area of 2 basketball courts. It weighs over 1,000 tons by itself. It heats Titan's metal to 700 degrees Celsius and fires it into a mold so fast that air bubbles don't even have time to form inside the metal. That air bubble detail matters more than it sounds. Air bubbles trapped inside metal are like invisible cracks. The part looks perfect from the outside, but under pressure, those hidden spaces become the starting points for fractures. By injecting the metal too fast for bubbles to form, Xiaomi gets parts with the kind of solid internal density you normally only see in aerospace components. Here's what this machine actually does in real production. The rear floor section of a car, one of the most structurally important parts of the whole vehicle, normally requires 72 separate stamped steel parts held together by 840 individual welds. The complete process traditionally takes several hours and many workers and machines. Xiaomi's hypercasting machine produces that entire section as a single piece in 100 seconds. 72 parts become one part. 840 welds become 0 welds. And on top of that, the single piece section is 17% lighter and produces 2 decibels less road noise because there are no tiny gaps or imperfect welds vibrating at highway speeds. But Xiaomi didn't stop at the chassis. They did something even more interesting with the battery. In almost every electric vehicle on the road today, the battery is a giant, expensive box bolted underneath the floor. It just sits there as dead weight that also happens to power the motors. It doesn't help hold the car together. It doesn't add any strength to the structure. Xiaomi asked a simple but powerful question. What if the battery were actually the skeleton of the car? This is what they call CTB technology, or cell-to-body. Instead of a separate battery box bolted to the frame, the battery cells are built directly into the chassis structure. The top of the battery pack is the actual floor of the cabin where you rest your feet. The cells below aren't just storing energy, they're actively helping hold the whole car together. Then Xiaomi did something that sounds strange at first, but turns out to be genius. They flipped every battery cell upside down. Every battery cell has a small pressure relief valve, a safety feature that lets hot gas escape safely if the battery overheats. In a normal battery pack, these valves face upward toward the passengers. To protect people from those valves, engineers have to build thick protective layers between the battery and the cabin floor, necessary but heavy. When Xiaomi flipped the cells, those valves now point downward toward the road. All that thick protective material between the battery and the cabin is now gone. The total thickness of the battery and floor combined dropped to just 120 millimeters. About as thick as a hardcover book. The result is almost hard to believe. The Xiaomi SU7 Ultra has a torsional stiffness of 51,000 Newton-meters per degree. A Ford F-150 Raptor measures around 25,000. The Xiaomi sedan is twice as stiff as a trophy truck. It's also stiffer than a Bugatti Chiron. That rigidity is what makes everything else work. When the chassis doesn't flex under any load, the suspension does its job perfectly every time. The tires stay flat against the road through hard cornering. And all of that was built to handle 1,548 horsepower from 3 electric motors, each one spinning at a world record 27,200 revolutions per minute. Most high-performance electric motors top out at around 20,000 revolutions per minute. Xiaomi's spin 35% faster. Xiaomi CEO Lei Jun has been clear about the company's ambition, stating that the SU7 line is a dream car project, aimed at making Xiaomi a top global EV brand within 15 to 20 years. Given that their latest YU7 SUV received over 200,000 orders in just 3 minutes, that dream is looking less like a vision and more like a reality that the rest of the automotive world is scrambling to catch up with. That's it for today. If you enjoyed the video, please like, comment, and subscribe for more boxing updates.